right now. Okay. So 35B in the homework on Chapter 15, we are looking at a luggage situation, and it says some information, so let's kind of go through here. The question, I think we need to read the problem first, and I believe it's a tree diagram problem. For the quiz, how do I recognize when to use a tree diagram? Okay, what am I looking for in a problem? Not always percents, because percents can be used in a Venn diagram, they can be used in a lot of other things. So percents alone is not enough. That alone is not enough. Hunter? Yeah, but there's like two different things going on. It's called multi-stage probability. Okay? So let's read this problem and let's make sure that we have multiple things going on, because if that's the case, that tells me, remember, like, you have the flu or you don't have the flu. And then the other thing is you can test positive or not test positive for the disease. There's two different things going on. That was the example that we did in class. So in question 35, it says Leah's flying from Boston to Denver with a connection in Chicago. The probability her first flight leaves on time is 0.1 of 5. Okay? So we're going to look at first flight, and it leaves on time. It's going to be 0.15. O'Hare is notoriously late getting from people flying out. All right, so we have 0.15, and then we have not on time. What would that be? 0.85, okay? And then it says if the flight is on time, right, so now we have to figure it out. If it's on time, we're up here, right? If her first flight is on time, the probability her luggage will make the connecting flight in Chicago. So we'll make the luggage, so we'll say this is flight. The first thing that's happening is the first flight, and the second thing that's happening is the luggage making the connection. Okay, so those are our two separate things, as Hunter said, that are happening, which is why a tree diagram kind of works in this situation. So it says that the luggage will make the connection is 0.95. 0.95, the luggage will work. How do I write that? So we'll say luggage, check, the luggage makes it, or the luggage does not make it. How about that? Okay? Just kind of putting it in context. So 0.05 would it be here? Remember that each branch of the tree has to add to be 1. It also says if the first flight is delayed, which now we're down here, the probability the luggage will make it is only, so luggage makes it, luggage doesn't make it, is going to be 0.65, which means now down here we're down at 0.35. Okay? To go ahead and make those final parts of the Venn diagram here, the flight's on time, the luggage makes it, that would be you multiply across that tree branch, then I have 0.1425, and then over here I have 0.0075, going across not on time, luggage still makes it, we still have a 55%, 0.5525, and here we have 0.2975. We should double check that. What should all these things add to be? Okay, making sure. And good. So we have our tree diagram. Let's go back to the question now. The question for part B is what Brenda was asking was, what is the probability that her luggage arrives in Denver with her? Okay, so what does that mean exactly? Well, that means that the luggage arrives right there. So the probability that the luggage arrives, okay, is going to be the probability that, well, we'll just look at it this way, rather than write the formula out. Would you agree that the luggage arriving is simply just going to be the luggage arriving and the luggage arriving? Is those two things added together? That's all you have to do, other than write a whole context.
Probability the luggage arriving
is not, yes, they have nothing to do with each other. Okay, they're all in the pot. But one doesn't affect the other. Another question. Say it loud.
39.
problem 39?
39B, but 48 we show like the mathematical problem for
Which one was it? 39B or
39B.
39B first. Okay. Let's look at that one. We're running out of time here. Let's look at 39B. 39B talks about absenteeism. It says the company's record indicates on any given day 1% of their day shift employees and 2% of their night shift employees will miss work. So what are my two branches? Day and night shift, right? Those are our two things that are going on. So we have day shift and we have night shift. Okay. And then what is the second thing going on? What is the second thing? Whether or not they are absent or not, right? So we have absent, what do you say, present, that's probably better. Or if we say not absent, present, that's much better. I'm going to dig more. I'm going to go to war, okay, let's go. All right, how many people work day shift? 60%? Which means 40% work the night shift. It gave us a percent. Okay, absent.
Okay, so when you're doing a tree diagram, are the factors always dependent because the probabilities change between different, so it's never independent.
Exactly what you just said like 2 minutes ago.
Oh, sorry.
No, that you didn't hear it.
Oh, okay.
And you're exactly right. That's why we use a tree diagram with conditional probabilities. They're not always dependent. We would still have to show that there are ways for them not to be dependent. But often they are. It's kind of like a contingency table. They're not always dependent either. They can be independent, but they're often shown that way. So it's not a guarantee that they are dependent, but the calculation will show it if it is. So you've got to show the calculation. The probability of night given absenteeism is equal to the probability of night. Right? So that would be an independent situation. And you're going to show me the calculation. Okay? All right, sorry. So to continue on, we have 0.01 or 1% are absent from work, which means 99% are present. And the night shift, we have 2% that are absent, which means 98% are present. I'm just going to go ahead and do my end probabilities on the trees, multiplying across the board. We have 0.0006, right? We have 0.594. That whole thing just shakers at me. 0.008, and then 0.392. Do those add up to be 100? Okay, good. And you said B, right, Tammy? Okay, so B says, what percent of employees are absent on any given day? Well, again, this is just like the other problem. We're just going to add those. Just like the last problem. Just like the problem Brenda asked. Okay? So, can we move away from tree diagrams for a little bit? Since you have other questions that could be on your quiz, because it's not just on tree diagrams. It could be on Venn diagrams, it could be on multiplication, it could be on conditional probability, it could be on the addition rules. Looking at your probability practice. Are there, since I graded those and gave them back to you, are there any questions on any of that that you weren't sure of? You added those? Was it asked you, what's the probability you were absent? Well, you can work through the day and be absent, or you work night and be absent. Or one or the other. Yep. One or the other.
So like the practice test, the practice.
Practice test the probability practice.
The probability.
I can't hear her. Okay.
The question number 8 was really confusing.
Is that? Are you which one are you looking at?
Is it probability practice test?
Practice test. Okay, that's something different. Can you look at the probability practice?
Oh.
I think I just graded. I'd like to look at number 7. Can you look at that one? That was like which shipping company can give you more points back or whatever? There might be a possibility usually I give you points back on that question. That's why I kind of want to go over it. Okay, on number 7. So this is how I approach number 7. Okay, so let's look at it. It says 2 shipping services offer overnight delivery of parcels. Both promise delivery before 10 a.m. A mail order company ships 30% of its packages with service A and whatever with service B. We have failing to meet deadlines and blah, 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 blah. So don't we really have 2 things going on? We have the first thing is they either go with company A or B, right? And the second thing is either they deliver on time or they don't. Would you agree with that? So I see a multi-stage probability. I see tree diagram in my head. Okay. So I'm going to go ahead and just draw that for a minute. So we can have they go with company A or they go with company B, and then we have that they either are late or they're not. So, it says here that 30% of its packages go with service A, which means 70 go with B. And then I think the wording might be weird here. It says 70%, service A fails to meet the deadline 10% of the time. So they're late 10% of the time, failing to meet the deadline. Which means they're on time 90%. It says service B fails 8% of the time. So they're late 8%, not 80, sorry, 0.08, which means 0.92 here. Agree with me so far? And then it says, suppose you made a purchase and it was late. Which service was more likely used for your purchase? Well, here's how I approached it. Well, you can, what's the probability that you went with A, given that it failed? And what's the probability that you went with B, given that it failed? Because it says, suppose you made the purchase and the delivery was late. So it means you're given that it was late, what's the probability that you went with A? Given that it was late, what's the probability that you went with B? Anybody, I know Charles did that. Did anybody else do that?
I did that, but like not like I just like because I already like it makes a lot.
Most of you just looked at these 2 probabilities and compared them. It's honestly not enough. Okay? That's where we had to talk about it a little bit. You really need to look at the conditional. This is A and late, and this is B and late. You can't just compare those 2 things. You really have to look at the conditionals. They're different things. Okay? So I think that was the issue there. Do we need to go through how to find the conditional, or do you feel comfortable? Yes? Can we go through that? Okay. So, let's do one at a time, okay? So the probability of A given fail is the probability of A and fail divided by the probability of fail. Okay, I want to make sure. All right. So let's plug in our numbers. So A and fail, well, that's going to be A and late. So point what? 0.03. Okay. So that's this branch, this top branch of the tree diagram. And then probability of fail is going to be 0.03 plus, because we're really looking at both of these are the 2 things that fail, are they not? So what is 0.7 times 0.08? 0.056. And so we're going to add those 2 things together in our denominator. Okay? And when I do that, I got 0.349. So the probability that I went with company A, given that I knew it failed, would be about 35%. Okay? And then I would do the same thing with B. And I would get a different probability. I actually got 0.651 there. And you can I didn't see that probability anywhere in the first sentence. I was looking specifically for those 2 numbers. Well, you just all right. Anything else I can help you with? What does or mean? Add this. Please remember to subtract out the intersection. section, use your formula. On the quiz, please, please, please make sure that you are writing the context and you are plugging in the numbers. Don't just give me an answer. I don't know where that answer comes from. Okay? That's what.
On the first, what is it like some of the statements are like, you have this in the middle of the sentence, but it's just a state, like, if it's going to be different or if it's going to be
So that's the hard part, is understanding when to use a conditional probability. And I hear you and I feel your pain. I really do. What follows the is often what you're looking for. Okay? So for example, let's look at this problem. What is the probability that how about this? Your package failed. What's the probability given? What's the probability that when you went through A, company A? That'd be this right here. It's hard to be on a fly to come up with wording, but I know what you mean. It's just different every time, so I can't really come up with one set way. Just find the word is. I agree, and what follows that, the second half of the sentence is really what you're looking for often. Okay, if the words given that aren't there. I don't know if that helps you or not. Okay. Yeah.
So,
Uh-huh.
probability B given A equals the probability of B.
Yes.
And then can you say exclusively the probability of B given A?
No. No, the probability A and B is zero. Mutually exclusive means there's no overlap. A and B can't exist. It's nothing to do with this problem.
Well, the probability of B given A.
Would be the zero be on the top anyway. So that's fine. So yes, they would happen to be that, but that's not what you're looking for. Yes, that would work because the formula is B given A and B at the top. But really what we're looking for is the and, not the given that. Not the given. You're kind of good. You don't want to. Yes. Clear your desk off, grab a folder while we're waiting. Go ahead.
When you're talking about what you're looking
Your homework is on the board here. I would like for you to go ahead and read the next chapter. It is on probability distributions and being able to add, subtract, multiply, different kinds of probabilities, a little bit different than what we're used to. Combining things and anyway, read the chapter, do this technique, and I want you to look. The first two problems are just on expected value. So it's